We working? Yeah, it looks like we're working. All right. Let's, I'm getting a little distracted here with this stuff open. I am going to switch gears here, move back to our HTML template stuff. I got a lot of projects open. I'm going to switch here. But I've recently been informed that Smart Client in their, let's see, this is the wrong directory. In their, what's this called? LGBL build, they include their DTS files. And it might make sense to say, hey, could we try generating some JsInterop from this? I've had a couple of people ask about this because the Smart Wit client, unfortunately, is a little hard to work with, and they're totally uninterested in updating it to something that would be simpler and easier to maintain. So I'm going to spend a little bit of time here seeing how much trouble we would be in to try and generate this. Unfortunately, the DTS looks like it's generated by some tool. We've got line wraps that are wrong. Nothing is indented properly. We should indent here to say, hey, this is a member of this interface. Oddly, they redeclare object. I don't understand why that would be the case. Now we've got a TypeScript object and a smart client object, and they redefine array deliberately too. Generic extensions to array. So if I'm reading this correctly, they actually define a get method and a get length on array. It's not a proper array. You can call these on any array. I'm really hoping that I am misunderstanding this, that they are not monkey patching the array type. I'm really hoping that I'm misunderstanding what that is there. Let's look for that real quick, just see where we can find that. Well, there's a lot of stuff here that does that. Let's try something else. This is not working. All right, and now we are finding all the files that don't match. Okay, so here is a runtime file that matches array.prototype.class. Good lord. They are monkey patching it. Array.create is just a reference to new instance, which they already made there, which itself is a function that makes an array and attaches a property list. Array.prototype. Oh no, that's it. Create from item args. Call slice on it instead of array.of. Maybe this doesn't support array.of. This is probably really hard to read on the stream, isn't it? Yeah, it's unfortunate. Let me switch to a new terminal and try that instead. Let's see, Command T, Command F5, CD downloads, smart client, and then what file was it I was looking at here? Oh, this is just the whole thing. I was just saying, show me everything. All right, that works. All right, so here is the original contents to get this file here, which is already minified. It'd be nice if they had an unminified version of this. This is the development file. I could pop it into IntelliJ and have it figure it out. The specific things we were interested in were a get method. So if I look for /.get equals ISCA is array, then it returns array get, which is just the sub _1. All right. I'm sure there's a good reason that this is done. I cannot possibly imagine what it is, because this is after their minification has kicked in, and ostensibly compilation to make things better. The only charitable explanation I can think of is that this is to make Smart Gwt easier. That way they can just directly call native things, but that would really only make sense with JsInterop. with JSNI, it would make more sense just to write the method body anyway, since you can't directly call methods unless they just want to be able to say, you know, array dot, you know, square braces and then inside of quotes a get or something silly like that. That's very weird. All right, let's see who assigns ISC array. Or ISC.a. Is this like a helper? Yep, it is. ISC array is array prototype. That's interesting. So they're directly manipulating the prototype here going forward. Which could make sense to be able to say, hey, I want this shorter. It's like a sort of minification. But they didn't minify this thing over there. So they could have saved a bunch of letters by doing that. Okay, anyway, confusing. Let's look at the DTS file again. So if we find in here for rep DTS, we got a couple of them. For some reason, there seem to be 2 copies of them. And they are identical. Both copies are exactly the same, so naturally you ship both of them in the same zip. Again, I am certain there's a good reason for that, and it's not just that it's easier to not... It's easier to just to follow the... I'm very biased. It's easier to follow the JavaScript way of just, let's just throw some files in there. It'll work when it gets to the browser, or not. Let's look at this real quick again. So we got this, this object. We redefine object. We redefine array for the purposes of this file, which now has some things like get instead of square braces. We have get length instead of dot length. You can put members on interfaces, so they don't even have to do this. Unless they want to artificially change what the length of an array is by pretending it has more items or something. Return the list at a specified position. Okay, so that's kind of like a sublist method for Java. Partial number. So partial is a TypeScript type that I can't remember the specifics of. I think what that means is we're just going to have an array of specific items we want, and then it will return an array of whatever was in there. Now, why they provide any here instead of t, I am certain there's a good reason for that, other than just we don't understand TypeScript generics. But I couldn't guess what it is beyond that. Okay, ISC list. Looks like they define their own list type here. Contains all of a list. So list rather than an array. Let's take a look at where list is defined. Must be an interface. There we go. It's non-generic, so we don't have the ability to test what the types are going to be coming out. Why are we using TypeScript if we don't have types? So the more I look at this, the more concerned I am that if we try to generate JsInterop out of this, we're just going to make people cry. Because you're going to get this and you're going to say, oh, great, there's TypeScript types. That means someone has actually thought about this. And you get it into your Java code, and your Java code says, oh, look at this. Everything is an object. It's 2003 again. We have no generics. But all these little oddities, formatting oddities like this, they define their own integer type. I hope that that is well defined to actually restrict it to certain kinds of numbers. Anybody want to take a bet if it is or not? No, I understand that. There we go. Class integer. No, maybe interface integer. No. Where do they define integer? What's the first definition of integer in this? There we go. Here's a type. That is a type integer. They're putting closure or JSDoc types as well as this. So I'm guessing this is this JS type. I'm sorry, this TypeScript is actually generated from JSDoc. That's my hunch for what's going on here. Hey, you want to offer a promotion of go away? Where's the ban button? There it is. Cool. Okay, let's see where integer is defined. I can't imagine. There we go. Oh no, that's not the definition. That's just the first. That's just an earlier usage. Let's go to the top of the file. ISC integer is referenced here. We still haven't defined it yet. Sometimes we define ISC integer, sometimes we define plain integer. Well, there's other ways to define types in TypeScript. Like type defs, basically saying integer is a number. And it's probably going to come to that to say, what exactly do we need to do to define this? It would also help if I was using a tool that was actually designed to handle TypeScript instead of a terminal. But if they can't be bothered to have actual types, why do I bother with actual tools? That's where I'm going with this. We had a positive integer I saw up above. That would probably be less frequently defined in here and easier to look up the specific definition. Let's try that. Type positive integer equals integer. Okay, so there's probably type integer equals number. That's my hunch. Yep, type integer equals number. Decimal numbers, for example 5.5, are not allowed. Of course, if you actually assign a 5.5 right there, hang on, how do I point in a screen like this? I can't figure it out that way. If you actually assign 5.5 to an integer in TypeScript, it's going to say, oh yeah, because it's a number, so that's totally allowed. Null is allowed. Okay, okay. And in fact, not a number is allowed. Infinity is allowed, because they defined it to only be number without restricting the possible values to say only positive numbers in some way. Oh well, TypeScript is kind of cool. It's got some warts, but if you use it this way, you're just making your life more difficult. You're not getting the advantage of the types. You're not helping the people who are using your tool to properly get your types out of it. But at least there's a TypeScript file for this. So let me make a quick note here. We had a specific customer ask for this feature, and I'm going to have to let them know that it doesn't likely make sense. I am not going to look at this right now. We will play with T-Sickle in a little bit to see if we can make some magic happen out of this. T-Sickle has had a number of updates since I last was using it. T-Sickle was dropping generics when it was generating a record that extends another record, or rather a struct that extends another struct. I filed some of these issues in the Angular T-Sickle repository. No, not in there. In Google's JsInterop repo, because it was their specific bug for some of it. But this one I haven't been able to update. T-Sickle has actually stopped releasing a binary that you can use. And they did it in a point release. T-Sickle, let me pull this code up so we can just talk about it real quick instead of staring at this black screen. There we go. So T-Sickle is the tool that takes TypeScript and generates things that we can use from Clojure. They used to have a binary file in, let's see, what was it? 27.1 or something. Where did the 27.1 release go? Let's see what version it was in if they had that last. I mostly use this when I work on Deep Haven community code. This is all not open source, but source available. Anybody can read this as long as you're not going to make a data provider out of it. It's effectively free and clear to use. So let's pull open my code gen here for TypeScript. Check out web. IntelliJ is getting a little laggy. Oh, it's still opening the file, that's why. And we're going to change it by kicking it back in time a little ways here. Okay. We want to look at the web stuff instead. Man, this is crunchy here. This is slowing down a lot. I would really like to use my computer while it is looking at files. There we go. Web, backplane. Got a Docker directory because I always run the builds in Docker just because as hermetic as Bazel ostensibly is, every once in a while Bazel stuff totally just writes to other directories. Or, like they had this week, downloads releases from GitHub and doesn't actually check to make sure that they're consistent between, or that they're stable, and assumes that they will be stable. Okay, so the build sh shows that we usually build this by looking for a binary in node modules bin tcl. Let's check our package JSON for which version we have been using. 37.0. So if we go to 37.0, I was off by 10, I guess. They ship an executable in here somewhere. Oh, right, they mention it in the package JSON. That's how this works. I don't run a lot of NPM stuff. This bin source main. Oops, that's test. Let's look at source, look at main. And main is just a little bit of glue to say, hey, here's how we grab the command line settings, here's how we print usage and other helpful things like that. Here's how we load up settings out of our arguments, and parse them and all that other good stuff. And then eventually in here, so quickly that I'll probably miss it as I page through here, here's the function that actually does the work. Generates into closure, compiler ready JavaScript, which is what we are after. And then here's the main that actually does all the work and says, okay, try to do the thing. If you can't do the thing, then fail out and give the user something helpful. Otherwise, do the thing and then print the results to somewhere helpful. So this is the little wrapper script around tcl.ts itself that we used to have. And in release 37.1 then, which is a point release, you know, ostensibly a bug fix release, the main file is gone. There is no more way of doing that. So if I look at history real quick, we see that in some example code, they decided, well, we updated the example, so let's just go ahead and blow away the main. Our main file, let's see, where did it go? Here's the demo. Let's see, they show it running by saying that will run plain TSC. We don't want to run TSC. We want to run tcl itself. Bazel bin, yarn link. Work on this and the main tcl at the same time. So where is the main tcl? Import that as tcl, invoke it directly here. So it looks like this demo is actually, yeah, here we go. It renamed source main ts into demo ts. And so now this is the binary that you run. So what happens to this file over time? Can we still use this so we can directly invoke it? Let's update from here to master. think they're still calling their main branch master. Yes, it is still here. Okay, so this should still work. We should still be able to invoke this as a main. It will say call out to node to invoke the rest of these contents, and then things will work properly. But from their documentation at this point, it says that to use this tool, it's a library intended to be used by a larger program that interacts with TypeScript and Clojure. So you can either use Google directly with Bazel, or you can use TSCC, which is now a wrapper that covers both of those. Now, unfortunately, we don't actually want to run, to take TypeScript, turn it into JavaScript, and then compile it out. We want to say, take TypeScript, turn it into externs, and those externs are what we're going to lean on to generate JsInterop. So here's our starting point here, grabbing this main. Unless anybody has a burning desire to see this happen, I am disappointed enough by those externs we just found over here that I'm going to move on from this and come back to it later. It's something I have to do eventually, but unless someone really wants to see bad TypeScript generated into worse Java, I think I can find something else to occupy my time with. So let's close out of this, switch back to HTML templates, which is what I was leading with for the stream. The work we started getting going here was a whole lot of code gen last time. So it doesn't quite work yet. Got a whole lot of code gen that's happening here. Let's just summarize this briefly before we continue. We say check to make sure that it has this DOM element interface that we implement as DOM element. Eventually, we might make this optional and support multiple different things that are, hey, I'm a widget. But we have to say, we have to know what template and directive are because these are part of the library itself. So our template interface, just as a reminder, has this value annotation. If we look at where we're using it, we can do things like make an order form that has HTML in one big string as part of our class. And then inside of here, there are other classes that'll be referenced. This tab panel is the same as this tab panel class. So we can go to tab panel and say, okay, what's its HTML? And then all of these will bind at runtime to whatever the type is, whatever the model is you've got to represent your data. And it will, in the same way that Angular and React and Knockout and all these other libraries do, will generate the expected HTML. The difference, the chief difference here is instead of generating HTML fresh every time something changes and then using VDOM, we are going to directly bind the DOM element here, the text node in this particular case. We're going to directly bind this attribute of this element to the properties that are being referenced by these curly braces. So these will do strong type generation at build time, figure out how to access recipient, and then within it, how to access phone. And whenever that changes, modify value. And once we have an event system, because we don't have that finished yet, when this changes, how to assign back to phone. That way anything else listening to recipient would notice that the phone property changes. So for example, this here would listen to recipient and pick up the update. We don't have a recipient view, so this doesn't actually do anything, but this is the idea how you would say, here's your view model that I want you to render off. So what we have so far is just to say, hey, go ahead and find the template element and look for anything that are directives on it, because we're going to need that later. A directive, by the way, is the notion of saying, hey, here is a thing that's going to do some updates. It is kind of like a React hook. If we look at these examples, in this particular case here, this is going to say, grab this list of items and then unfold these contents to apply it. Apply this template to every single one of those contents. So we won't get into that now. We did that a little in the last stream. We're going to iterate through each of the things that happens to implement template. And we're going to say, go ahead and grab the template annotation and grab the value out of that. We could probably make this not use the annotation mirror call, but just directly call value because we're going to be compiling with that present. Then we grab the HTML itself, and that is the string contents from this giant thing here. We parse that. We've already done all this work already. We parse that. We've got a language here that says, okay, here's what DOM elements are, here's what components are, here's where you're allowed to have white space, here's where you're allowed to put closing tags, things like that. Now that we can parse all of that out, we get a document. The document represents the entire HTML tree you have and all of the variables you're binding. And then we started going through and actually generating some code. I think we have some leftover generated code. We did everything last time except for what does the structure of this thing look like. So for example, the order form that we just looked at, in order for this abstract class to be useful, it has to correctly expose this as-DOM element, and it has to correctly expose, as part of this view interface, set view model, get view model. And those need to have some specific details. So here is the generated implementation where we say, okay, there's some factory. And a factory is basically a document to say, create a text node, create an element, create an attribute, things like that. And here's the root element that we're going to render. So when we return as-DOM element, it will return that root. All of these are created with a factory. When we end up creating child components, we will pass the factory. When we end up creating DOM elements, we'll use the factory. And then if you set view model, we'll say, okay, here's the new view model. Bind is the implementation that we're about to generate here to say, I have a new view model, presumably. Let's go ahead and rebind that. We might even update this to have an if check here to verify. For those keeping up with, hey, how should we generate this at home? Because we are extending an abstract class, which might have its own state or other things like that. You probably shouldn't have your own state, but you could. We can't provide base implementations for this, even though this is pretty much always going to do the same thing. Assign it to a variable if it's not the same, and then call bind. And bind is going to be our functionally abstract method that we declare here. So, okay, so now we have the basic scaffolding here. We need to implement bind. We've already done this once by hand, and here is what that bind method would look like. So this is actually checked in code. I don't have an underscore here. Notice that's the difference between this one here. Create order form underscore impl. In Java, when you generate code, there's sort of a expectation that you will make it clear that it's generated code. And one of the ways we do that is this generated annotation to say, hey, this is generated, and here is who generated me. And another thing you can do is put in underscores. Just to be clear, you probably don't want to reference the generated implementation when you are when you're writing your own code. You want to reference the original implementation, and if you want to make changes, that's where you change it. You don't want to change the generated stuff. So this is our handmade implementation. We have a to-do that I forgot to do something here, and then we carry on to say, okay, now we need a div. So we're going to generate this document.createElement div. And then we need a tab panel. Okay, how do we create a tab panel? It's going to be like this. We're going to pass in our own factory, and we're going to instantiate the new thing here. How do we assign this attribute? So each of these different things that are present in the document here have to be reflected in the bind method. And as we finished last week, let's just go ahead and close everything else here and make it big. We have the tooling in place to say, let's see, where's the hard part? The bind method. Generate bind method for has-DOM element. So right now this is very specific to has-DOM element, and we know that we need to go through and build these. If you see a DOM element, we're going to say, here's the type of the element, here's the name we're going to assign it to, factory.createElement, and we already named it factory up above. We defined the field factory. So we're using Java Poet. If you're not familiar with Java Poet, this is a nice tool to say, get some of this work done for me so I don't need to think too hard. So we said here is a method, which is a constructor that will assign factory. And then somewhere we define the field. Here we go. We make a private final field called factory of type factory. So we can just pass the class in there, and the code generation can figure out what we meant there. So let's make things a little less ambiguous down here with factory and just put this just in case we happen to have some other factory value floating around. I have a naming tool that will generate names as we go. Let's see here. Name equals namer.next get tag name. So in theory, if you had a tag name called factory, this implementation here could just return factory underscore how many factors have we seen so far. If we've seen 0, then it will just start off with factory 0. That's the idea. I got stuck here on how do we actually append these, because we need to have 2 different ways of appending. We need to know how to append, let's see here, DOM elements to DOM elements. So your parent, let's see, make sure it reflects nicely for how it looks on the screen. DOM element here is a parent, and then a DOM element child. So you need to say, take this thing and append it to here. Okay, what if it's a component child? You need to say component, unwrap it to get the DOM element, and then append it to the element parent. Okay, if it's a component parent, this is case 3, and with a DOM element child, we need to say append this to your list of children, whatever that happens to be. The component will have to have some property that indicates I can accept children, and when my list of children is modified, I will re-render my content to the screen. And then in turn, we have a component and a component. So if you have a component child, grab the DOM element, append it to the component parent's child list so that it notices the change and correctly rebinds. So there's a little bit of gluing together we have to do there. So I'm just going to comment these out for the moment and just put a little method body. Can I write a comment? Can we just add a comment like yeah, this might work. Retrieve name. I'm just going to put spaces in here just to be really clear we don't know what we're doing. So that will be, that might generate something vaguely usable. Let's try to do a build here and see if we get some output. Because this might get us our hierarchy of children. Oh no. Java 17. We've assumed Java 17 for this project. It's just a lot more fun to use latest features. Even though latest is now 19. We'll get there. Okay, so something's wrong here in the generated code. Cannot find simple view model. Oh, I typoed something dumb here. Sorry, Gitter's being chatty this morning. All right, so that still has nothing. That is disappointing. I screwed something up here. I must not be returning it properly. Let's see, add code will be this whole block. We're going to make a method body. Add statement just returns this, so that's totally fair. We accept this. Maybe it's because I'm not visiting the children properly, the document. That's probably it. Let's get rid of this one too. I haven't actually tried this, so this is going to be kind of fun to see what happens. And now we got expected type, but was null, so let's turn on the stack trace and see where I blew up. So this line here expected to have a type, component type, or impl type. And I'm guessing both of those return null right now. Yeah, they do. Okay, let's just return a... What if we return these to a class name? Class name dot best guess of component name, and just say, hey, can you figure out something that is not totally bonkers? This is technically still correct because we want it to be parameterized eventually. There might be generics going on here. We'll get there. Max C3000, thanks for joining us. Here's hoping you're not a spam bot too that I have to ban. With a name like that, I'm guessing you're a real person. Oh, I can't type, can I? Best guess. Yeah, okay. We're gonna cheat with this and say get the name. Can we get the name easily? How do you get the name of these? We need to move it, pass it to a declared type. Oh, this is not going to work because I'm guessing I take the component name and then I component type and then I say get the implementation, which is now a yeah, I just changed it to a class name. Okay, that's irritating. Let's just return the component type for now because we can't guarantee this is going to exist at all. And then we'll say get component and revert this one also to type name, type mirror. These probably should be declared type now that I think about it. It's getting a little loud in here. All right, so now we want to say from our environment, get element utils, get a type element with that given component name, and then get the type mirror out of it, and we know it can be safely cast to a declared type. So assuming that that code is vaguely sane, what do we got here? Type, declared type. The problem is this is going to be null always. Oh, no, it isn't. We just don't have a package attached to it. I'm going to shut the door here. Be right back. I don't know if you can hear that, but I can hear it. We'll read that later. It's not important right now. Nobody's chatting in here? Yeah? Okay, cool. The problem is this component name is basically the equivalent of reading this string here. This is just the component name. We need to do a lookup on this to our list of components, find out where it says tab panel, and then from here we can see, you can see this pop up here. It shows that it's, it doesn't actually show the package name here. Well, anyway, we know the package. It doesn't have a package name. That's what's going on. Because I never put this in packages. I just said, hey, this is close enough to what we meant. We'll put it in packages later. So it might actually be accurate now. Cannot invoke this because it's a null. Yeah, okay, fine. So we do need to actually finish that lookup here. And grab the components property. And grab all those classes. And do the lookups. I was hoping we'd have some structure. What if we just stick class in there or something? Java lang class for each of these. Let's see here. Or object. We just do environment dot. Do we have object as an easy type to get? No. We'll get element utils. All right. You need to be convinced of that through a cast. We'll fix that. Implementation just reflects the same thing. This might work. I mean, it won't work, but it might generate content that appears at a glance to be valid. Yeah, so the complaint now is that the code doesn't compile, but we have structure now. Check this out. That's not what I meant to do. So here's our ideal generated stuff. We made a mistake here. It shouldn't have DOM element here. It should just assign to the existing DOM element. And it calls factory.createElement. I guess we could rename this here. Let's do Shift F6. Factory. That way it looks kind of the same. Sure, why not? And then we've got an object constructor here to say, it's a root, it's a root. Oh boy, they're all roots. So the namer did not work at all. I must not be correctly tracking what the name of the next thing should be. But it makes a div, it makes a tab panel, it makes whatever the first child in the tab panel is. We've got some structural pieces put in here to say we should root, append root. I can't tell what any of these mean, though. And I forgot new lines, so those don't look good either. All right, let's fix that, see if we can actually see some structure. Because if at least we have the idea that we're going in the right direction, I'm going to feel a little better about this, and then we can work out what this needs to look like. Because one of the things I said last call was that I was going to skip the meta model. The meta model is the model that describes the model that we're going to use here, of what your structure actually is. If we could skip that, the code writing goes a little quicker, but it will eventually get painted into a corner where we can't get more work done without just hacking it together. And this is that corner. We have found the corner. We are now painted firmly into the corner. Okay, so what's up with root? If a certain name equals root, or else name. So why is the namer, if names is empty, names compute, is it making a new namer every time or something? Who constructs namer? There's just one namer for the lifetime of the whole method. Next should say if names is empty, return a root. Oh, but it never puts that into here. Got it. So what we want to say is only your first one ever needs this. Okay, so this isn't going to work anyway because we need to skip the declaration for the root. Right, like this. All the other ones will look like object, whatever my type is. Let's just go ahead and say names dot put root 1. Right? Yeah, we always put 1 as our default. So that should at least fix this problem here, so that we get different names as we go through. All right, now we have root. It's capitalizing T for tab panel. So let's put a to-do for that, because I don't really care right now. Namer. Where did my namer go? All right. So now we have a tab panel, we have a tab item. These need to be instantiated properly, but we're fine for right now. We have a UL, an LI. Okay, so this part here, from the LI, this whole part here. So unfortunately, it did not append attributes or children yet, like text nodes. This is the part that should be all inside of here, where we say make an LI, and then we end up appending it to something. This is somebody else's problem right now. We're not going to worry about that just yet. The UL, did I never append the UL to the button? Oh, I did. I did here. Okay. So we need to replace that append with something else. I thought I commented this out. Yeah, this isn't quite right. We'll fix that. Here's the button being created. Append it to the tab item. Button gets appended to the tab item. I named the tab item line items, but it just called it tab item 1 and then tab item 2. So it made sure that we did not overlap the naming. It did that properly. And then it will append a label to it, which is what's happening here. Made a phone number. It tried to append the phone. Made another label, phone. All right, so let's try text nodes. See if we can get text nodes to render. This is not the right place for that. Here we are. Visit a text node. Okay. So a text node roughly is going to be, assuming it's not bound to anything. And this is the tricky part, because we might have a reference inside the text node, or it might be next to it. I can't remember if text nodes contain references, or if they are children. So for the moment, let's just say, what if we get a text node and just try creating method body dot add, and then we'll say node dot get text. We're going to need that as a literal to go inside of some quotes. So that'll end up being this.factory.create text node quote $L to say it's a literal. Please embed it properly. And that's add statement. Okay. So this won't actually assign it to anything yet because we have to append that as a child. Haven't done that yet. Let's try that. LV, thanks for hanging out with us. Okay, so we got the strings now. Or more info call. Okay, it doesn't understand white space, so that's a problem. So we actually want white space between these nodes. It skipped the references here, which is what we were expecting it to do for now. Here's the handmade implementation. We've got the hash, the slash. There's no space because it doesn't understand that. And then it put this whole string into separate words. Okay, we can get there though. It's close enough you can see it from here and understand what's happening. That is a parser problem. The language itself thinks that white space is its own separate thing that gets managed separately. I'm going to go ahead and mute this because Justin is real grumpy about some code he's looking at and wants to share it with the world inside of Vertispam. Okay, so we still need to wrap all this up too. That's going to be fine. We can look for directives and find those and make sure to segment them. That's an important point because we don't append child in quite the same way when you are in a directive. So that's a third case of appending. We already covered the case. Let me just pull this up so I can make sure I'm not just waving around the room. We've got a DOM element parent, we've got a component parent, and now we've got a directive parent. Because for a directive parent, we have to create a new fragment to append things. If you were paying attention last week, or 2 weeks ago, when we last had this conversation, we hit a discussion point around fragments and the fact that when you clone anything, whether it's a fragment or an element, it loses its event handlers because you don't want the same event handlers applying to 2 different copies of the same content, because that would just be silly to have 2 different places and they both trigger the same event handlers and you can't tell the difference. So clone just strips them all off as it goes. We will not be cloning this, I think. We will just be taking this fragment, I hope, and then in our repeat contents, we should just be saying grab your lambda contents, which comes from... Oh, where does it come from? Lambda goes into here. The unbound fragment goes into our directive. Our directive is implemented here in repeat. There we go. We bind it with the template. Bind and clone says it clones, but I'm guessing this is actually a lie. We're just going to bind it. Yes. Bind and clone is just the name of the method. We will not clone it as we go. We don't want to clone it because that would lose our event handlers. Okay, so this is actually not an issue. We don't need to worry about losing event handlers that way. To apply it, the whole fragment at once, since contents are contiguous, that is actually what this is doing here. So that's okay. It's just applying it all in one piece here. Okay, let's backtrack. Make sure that our clone method does what we think we want it to before I go all the way back. DOM node, clone. Yep. Okay, nothing calls clone node. Good. So we have these implementations, but they will lose event handlers, and that is on whoever calls them. So if your own UI code happens to call clone, you have to understand the implications of if you clone a DOM node, you lose handlers. Okay. So our generated code is here. We got something with some generated stuff here. We're not actually appending these right. We said there's 3 ways to append to a parent now. We've got the one where your parent is a DOM element. We've got the one where your parent is a component. We've got the one where your parent is a directive, like this. Scope creating directive. Because now, in this case, it's going to want to attach it to just a small template, which will be repeated over and over again. Because if you've got 10 things in here, you don't want to directly attach the li here, because what if an item is removed from the list? Then we're going to want to automatically remove that li and keep track of where it would normally be, especially if it's in the middle of the list or we need to change it. Anyway, that's not our problem. We think we've already solved this. This code looks correct. We'll see if it actually works. It compiles. It's close enough, right? Okay. So that's the third case we need to deal with here. We need to go back to our code gen and say, when you are appending a component, there are two cases to worry about. Oh, here's where we failed to comment out the right thing. So we've actually got 6 cases instead of 4 cases so far. We've got a DOM element where your parent is an element, a DOM element where your parent is a component where your parent is a DOM element, and a component where your parent is a component. In theory, each of these would handle their own cases. Now that we've got another case, we did have to do another else if to correctly handle that. I'm not gonna mess with that right now because I think that's more trouble than it's worth to go through and build this. I think instead we want to factor this out and just use polymorphism to say, there is some parent I've got. It accepts nodes. And there will be 3 implementations, one for DOM element, one for component, and one for directives. And we will say, hey, here is the contents, just append it. I will give you a DOM element. I promise it's a DOM element. You figure it out for yourself how to append it. Let's see. This should change some of these to be appends. There we go. ul append li, tab element append li. So we got to solve this. This is a separate problem. Tab element has a button. Tab element has a tab item. And then likewise, we're going to need a way to say, hey, there's some text content. Figure out what mode we're in and how we should append it. So let's go ahead and add a third enum in here. And watch as the compiler says, hey, actually, this is wrong now. It should really be a switch case at this point, but whatever, we'll be fine. If the mode is element, then we can do, first of all, let's just declare this. Something like, we'll do $T, $L equals, and then we will say $T is text node, and then L is namer.next text. And then if it's an element, the way you append to an element is you say, oh, I guess we got to keep track of the name, don't we? We'll call it text. That's a terrible name. We'll call it name. That's what the outer one is called, right? So this one's easy. We can say add statement of sorry, I'm getting distracted because I see that I screwed up. We will say add a new statement here, which is grab our parent, which has some name. So we'll just say L. It'll substitute it for us. Dot append. And then here is where we will have the child. So it'll be this dot name. So I really hate names. Now we got name and name. So let's just change this to be text node. As a statement, it'll automatically get a semicolon. Create text node of ampersand. That's wrong. We're going to need to unescape that. All right, let's try it out. We should get something resembling HTML. All right, so now we create a text node and we append it to the button. This is a proper DOM element. It found it, and it found the append method to say, hey, here's how you append some node child to it. We could actually simplify this and just say directly append the string here. That might be a good idea. We'll think about that. Let's put a note. Let's not put it here. It would make the code a little smaller if we just directly appended it here. And so that would look like let's get some quotes. It would look like this. So now it just directly appends a string. And again, we have overrides for this that work properly. DOM node does take a string. And this isn't just me making this up. This is how the browser works. The browser supports an append method that takes strings. Actually, it takes strings and nodes mixed, but we don't have overrides for that because in Java, it's a bit of a pain to say, oh yeah, this array can contain two different kinds of things that are unrelated. But in JavaScript, that's just, another day at the office. So now it's appending each of these here. We would love to group these up into one giant append, but again, that's a language problem. We will fix the parser to notice these white space and leave them alone. Okay, so that's more or less right. Let's handle one of our other cases here. Else if mode equals component. Now we need to do our I don't know the answer yet code. Let's go ahead and leave that as we have it here. Kind of like that. We'll just drop the to-do and say that's the correct way to do it. We can always come back and fix it. So now we need a text node. We need to put, let's see, we already got the text node appended here. We need to say some kind of method body dot add. And then here's where it's going to be the literal for the parent. And this is totally wrong, and we're accepting that it's totally wrong here. We'll get back to it and fix it. Because we're not going to build overloads that take strings here, because we're trying to interact with children. It's going to be something like this.children.add. And then two different things here. It's going to be, first of all, this.name and text node is the name of the thing we're adding. So now we add children differently based on whether it's a DOM element or a component. We'll have to see if we actually do the other version, because I know we're going to do this all over the place. Here we go. So this component here is supposed to have an ampersand inside of it, apparently. We take this text and we say tab item 2, children.add. Oh, we forgot a new line. That's embarrassing. Okay, so it really should be like this. So children.add text. Now this is probably pretty close to accurate. Tab item 2 is actually going to be a tab item. Never mind that constructor call there. Tab item 2 is a tab item which does not have a children property, it has a contents property. So we need to find a way to say, how do I actually append to these contents? Sometimes I said contents, sometimes I said children, because I wasn't sure what I liked better as an answer. If we look at tab panel itself, is where I think I said children. One thing that occurs to me is we could say children as an annotation, and that way we don't have to worry about which one it is. Just say, hey, you figured it out for yourself. You model this how you want. But this had better be an object property of an observable list of some kind of children. And then we can reflect on it to say, okay, if this only accepts tab items, then great, we'll directly append tab items. If, on the other hand, it accepts DOM elements, observable property of observable list of DOM node, now you can put anything you want in here. So I think that makes sense to say, hey, you can name it whatever you want. We don't have to make your bean fit our data model, our binding model. So I think I'm going to do that. We're just going to go ahead and switch over to our annotations part of the project. Make a new annotation for children. And put some quick docs on it. Object property of observable list. Oops. Right, that's not how you write Java. Let's do code of object property. Oops. So it occurs to me, what if you want only text inside of a thing? Let's make this a link. Oh, right, we don't have DOM element from here. We'll figure that out later. Wrong tag to do. What is the tag for to do? Is there no tag for to do? Am I just making that up? We'll just put it down here. All right. So now we need to fix this up so we've got good code, or compiling code anyway. What's up with tab item? Are you grumpy? There's a red line there. Did I do something dumb here? I don't know why that had a red line there. Anyway, it's better now. I think children might belong inside of template, but I think it's fine now, just to make a package full of different annotations. I have it marked here as DOM node. I wonder if that's what I mean. Yes, I think I do, because now you can put text nodes. So let's correct that. Okay. I think we hypothetically might also want to support just a single child, which would just be object property of the child, but let's worry about that later. Let's put a to-do for it. Okay, that seems reasonable. It definitely did not understand what I was writing here. All right, let's fix these generics. It's a less than, and then two greater thans. I get that right? Yeah, it looks right. No, it did not understand that either. You jerk. Is this correct? Yeah, that looks correct. Okay, cool. All right. So that seems to be a nice way to say, hey, what do I do, children? And so we're going to have some kind of a lookup while the code gen is running to say, it says I should have children. It says that this current component should have children. So let's do a scan here of the type and find out what the children property is. Seems like a reasonable limitation. You don't want to have two different lists and somehow have to figure out, do I interleave them? Do I just stack them? What's the correct order to handle that? All right. I wish these were being marked as to-dos. You prefer that, really? All right, fine, whatever. We'll put it there. There we go. Okay, let's see here. This is a fine to-do to delegate to later. We have to figure out how to unencode those or just directly say it's a entity already, somebody else's problem to inject. I think it's probably true that we could just say all of these things are safe strings anyway. We can just directly append them because the parser should have already ripped out anything that doesn't belong here. But I wouldn't want to bet anything significant on that fact. So let's see. Do we move on to attributes and just flesh it out before we get the model ready? I think we do that. I think that'll be a little better. References, we got to handle too. References go inside of attributes. I kind of like this model here where an attribute contains attribute text and then references. Let's check to see what that structure looks like. Open the language file and look up attribute. So an attribute, AST attribute, doesn't seem to exist actually, because I've got it marked as void. Oh, I see. Plain attribute is an attribute. Single quote attribute is an attribute text. And a plain attribute is defined as some kind of attribute name, and then either it is single quote, which is to say equal single quote. Yeah, equal single quote. And then contents are, oh boy. Plain attribute is an attribute. A plain attribute means I contain text and references, and or references. We also have event attributes, which are I contain references to Java, and directive attributes, which are my name maps to a directive type, and I contain expressions. Maybe we can Java doc this real quick to make this a little clearer what's going on here. AST attribute. think that'll be a little clearer as we try to parse this out and figure out what's inside of here. As we look at how we parse it, if you see an attribute, we now want to say, okay, my attribute can contain text or contain references. So as long as we're within an attribute, we are, let's see, building some kind of expression to rebind it. I think we did this already once. Bound attribute. I never used it, though. So let's just understand this code real quick. Maybe we can put it to use somewhere. We have a factory, of course. We have the name of the attribute, the generated value, which will be text node, expression reference, text node, blah, blah, blah. And then we've got this references thing to say what else could change. Not really sure what to do with that yet. And then we return a disposable list, which ostensibly is supposed to be bookkeeping that we can keep track of later, to throw away, to unhook bindings. Now, odds are that the weak reference work that Justin did in our underlying property library, so this is a separate project where property is defined and where we have all these various property types: object property, string property, integer property, Boolean property, computed property, which lets you run a function and see what the output is. All that has its own event handling internally and notifications of when changes happen. And right now I'm hooking into properties to say, hey, if it changes, here's the listener I want you to run. The references I see. Okay, so the way this works, let's see if we can find an example to use here. I don't have any interesting attributes here. We could try changing... No, that wouldn't work. This is on a component. Components work in a different way, where we set the property instead. We need a DOM element with an attribute. Let's look at phone number view. This has, here we go, here's an input with name points to name. So we only have the generated one. Let's make a manual version of this real quick. I already have one. Phone number view extends phone number view. We've got document. We're just going to go ahead and bind that to a field. We're going to rename it to factory to be consistent. Okay, so this is a own view model, which is supposed to be a marker to say, I will have my own fields, don't reference something else. We haven't implemented this properly yet. We have to deal with that later. Which means it binds right away. Which means we probably just are going to inline that bind method, but whatever. Oh, this is not final. Oh, it will be final once we inline it, but whatever. So this is going to be a input, which is going to be factory. Did I not rename this? I didn't rename the right one. F6 factory. Nope, F6 factory. There we go. So it's going to be factory.create element input. It's our only element, so we only have to have that one element created. It's going to first have a name. So we could do root set attribute name, but now we need a string to call on here. Name.get. So this is the naive way of saying, hey, we're just going to do one-time code generation, or one-time binding on here. Read from whatever our current name is and go ahead and set it here. But the idea of the attribute binding, the bound attribute, is that instead we say Here's the factory. Here is the attribute name. Really wish I could type. Here's the generated value, which is going to be name.get. Then we need the references. No way is this that easy. Let's see, required set. Okay, so we can do set.ofName. So this is meant to be the moral equivalent of this here. Odds are that's not how we're going to generate it. We're going to instead do it like this, just because it's simpler to build expressions in this way. So this is the moral equivalent of that. The advantage of this, though, is that it will work with any kind of contents that have bindings that need to be done. And this will update automatically. So if somebody ever calls name.set to something else, the bound attribute wiring here will say, oh, I see you just changed one of your references. Okay, let's go ahead and listen to the new one. And yeah, here's a change listener it's adding. Say, go ahead and replace this. Let's see, this only adds references on setup time. We will need to re-render this whole thing. Yeah, we'll worry about that later. That's not our problem today. The bug here is if we allowed this to be reassigned, whenever you reassign this, we'd have to rerun this particular bit of code. So let's do this for the other ones too. We've got type text. Because that's a constant, we don't need to worry about it. We can just say, I don't know why I commented that out. Is anybody here actually watching, or are you guys just letting me screw up on my own? We can say root.setAttribute of type to be the constant string text, because that one's easy. Value and placeholder we have to read also. So I'm just going to cheat these into existence. Now these are super easy because there's only one string in each one. So let's cheat this for a moment and change it to value. It may change placeholder to be something like is what you should type here. So if you have no value, it's going to assign the placeholder property to whatever's in here plus the rest of the string. And what we want to have happen is that this placeholder now is computed from the existing value. Every time that changes, we'll read the placeholder, regenerate the whole attribute in one go, and replace the attribute. So this should now say, hey, you just changed it. I'm going to rerun your formula here and set the value again to a new. Okay, last we need the change event handler, which is another kind of attribute. We didn't really talk about that yet. Roughly what this needs to look like is root.add event listener of change and call, let's see, there is an event handler here, so we're going to just say there's an event. I don't know if we're going to use it though, on change. So this is just that simple because the superclass already defines this and is doing something with it. And it's up to it what it ends up doing. Odds are it shouldn't manipulate static variables like this. It should directly change one of these properties. Once you start stepping away from, hey, I'm keeping my code stateless, the system can't make guarantees about how well it's going to work with rebinding. But that's sort of not our problem because it's just going to get updates properly. You have to make sure you don't have a reference counter in anything that needs to be updated magically. So we got event handling hooked up here. We don't have a way to re-emit this change handler up to whatever calls it here, but we do have a way of saying, hey, if you happen to change that DOM element, we could say value equals whatever the new value is. This is not smart enough to notice that you've changed the value in the DOM and update accordingly. For now, this is going to have to be what it is. All this is way over my head, but I'm still here. One day I'll be able to learn with HTML. Cool. So if you are just playing with HTML, this is a very different way of doing things. I think if you are still getting the hang of how do I just even create content, this is not for you. Except to say what do DOM elements do and how do we interact with them, and eventually how do I add listeners to them. This is meant to go a little further and say, I've got an idea of DOM content, HTML content I want to render on the screen, and I've got some data somewhere, and I just want to apply the same thing several different times in several different ways. Thanks for hanging out, even if it doesn't make sense. Feel free to ask questions or something. If I just wanted to get work done, I wouldn't have the camera going. I wouldn't have something like chat going. So it's okay to bother here and there. We've got like what, 4 of you right now? So, and Justin is working for the same company, and he'll be streaming on Friday too. Slightly different theme here, but we're working on the same basic ideas of how do we make this stuff easier to do. That being said, my coffee cup is empty. That's not going to last for long. We're going to have to go get that fixed. We've got some object event. Okay, so I don't have a type for this yet, so there's no easy way to read what that should be. We're going to need some kind of magic to say, how do I know what the new value is? So that I can say value.set new value. Some kind of magic's going to happen here. This is going to wind now as soon as it figures out, oh, wait a minute, you're supposed to have a new value. And I can't just say event.get new value. It's going to need to be something else like root.get attribute value. That's really gross to have to put here. Assuming I get to that still looking. Yeah, no, I agree. You'd probably do the live grid, I think, on Friday. I just mean that we're in the same ballpark of take data, apply it to ideas of HTML, make pretty stuff happen on the screen. So this is awful. So I don't want to force people to write this, and I especially don't want to assume that the code gen is going to do something like this. How do you take the element itself? You know, do you put in here on change with this and just say, hey, pass in the same element, the same thing that we're currently rendering right now? How do we provide that kind of context for what the new value is? We know we can write code like this. It's just a question of what does it end up looking like. This could also, just for another terrible idea, this could say value.set as DOM element get attribute value. Because now we're going to reach up and say, okay, so I'm inside of a thing that renders. Let me go see what that DOM element was and grab its attribute. That's not real cool either. So, but this is marginally better at least. Either we get a new value that way, or we talk to the DOM element. Where this really starts to break is if you render this in a loop or something inside of our own class here and want to pay attention to clicks. So here, if we render this loop here and you wanted to do something like on click equals do something. Wish I could spell. And you wanted to somehow pass in the current state, like index. Now we have to bind a different one on every single one, and we have to attach that thing there. Anyway, that's not today's problem. That's another day's problem. I'm just trying to work out getting the basics rendered in our stuff here. So if we say that this is the right way to build any kind of attribute that does not have, sorry, that does have references in it, then we can first of all say, okay, how do we build a model for this? We're going to need to attach that reference to the attribute. We're going to need to say the current scope is a attribute. So let's imagine something like right now we have mode and string to say what's the kind of thing I'm adding stuff to and what's the name of the thing I'm adding it to. If those were wrapped up in like parent or context or current context, then we could have more than one kind of type here and say add a reference to it at this point and to figure out how to render it. And maybe it's smart enough to update as it goes to say if you add multiple attribute strings, I know that I can just put them all into one text node and just assign the attribute once. But if instead you have a single reference in there, then I know I've got to replace the thing all at once, and Slack is unmuting itself. This may be a bug I can answer about. All right. Gave just enough details. Hopefully Justin can figure it out. Okay. Sorry, stream. Yes. We do real work too. It's not just hanging out on stream. We actually get paid for some of the work we do. Okay, so these will never need to be implemented. We were talking about making some kind of a wrapper that describes what is it you're appending something to. So hypothetically, if we had a private, what's the type going to be called? Parent context. Let's call it context. Context is a terrible name to use for something like this. Parent context, and then we assign context here to be a new thing that says you're an element context. So like. And we will give you a name. I don't know if it needs its own name, but it sure wouldn't hurt. So this encapsulates both the type, the mode, and the name. We probably need to keep track of the old one. That way we can reassign it and we can put it back when we're done. So we'll have to repeat that pattern elsewhere, because then we can get rid of these assigning in and out things. And we'll have to do it here too. So instead of an element context, we'll have a component context. Let's just play with the idea for a little bit longer. We're going to have to pass it, I think, just the node get component name, and then we will assume that the component context can look up for itself what its type should be. So there's going to be some other details, context, if you will. This is why context is a terrible name. Some other context that we could pass in to say, here's how you do your lookups. Okay, and then attributes need another one. Directives need another one. Directives are here. So we'll say current context, context, brief context equals current context. Current context equals new attribute context, which will have, I don't even know if we need specifics here. I don't think we do. I think we just have to execute it and put it back. So then we say current context equals previous context after we're finished with all this. So it'll be assemble visit children attached to parent. We'll get to the attached to parent in a minute. Let's put these in different lines. That way we can deal with it later. Current context will get reassigned here. And then directive is the last one I wanted to touch on, because I think that's the last case we have to worry about this. Attributes, attribute text just goes inside of attributes. Events are just going to be references. So let's say context, brief context equals current context equals new direct. So this is almost like actually having a directive itself, except we need to be able to pass lambda references to. We need to be able to pass references to it so that it can emit lambdas. We don't have the lambdas themselves already. And then we say current context goes back to previous context once we're done. And the directive really just needs, it actually won't do it here. It will, so this is going to be a little bit different. We can't finish a directive until we finish the element that we're in. So for example, if you make a repeat contents on a UL, we will say, okay, add an LI to that repeat contents, and then we might have something else to add there even after this is finished. So repeat contents is only going to be visited until it finishes items, and then it will say, okay, I'm done with that. Now let's visit this LI, which the parent of LI is UL. The parent isn't repeat contents. But we need to say, because that parent had a directive, we need to keep track of that directive and continue to append contents to that. Unless we do something like put the fragment on the stack and then pop that fragment when we're done. But we still need to know when you get to here, clear out that fragment from the stack. For those of us still picking up the programming side, a stack is conceptually just a stack of paper, right? You put new things on the stack. The only thing you can access is the thing off the top. So when you think about how people would wait in a line, the first person to get in the line is the first person to be done. If you got 5 people in line, they arrive in order, and then the first person who gets to the front of the line gets to have their work done. On the other hand, a stack, if you put all your work down on a stack, if somehow you were to metaphorically stack people, the last one to arrive is the first one you deal with. So the structure we want to think about here as we are looking at each thing, look at the div, look at the tab panel, look at the tab position, finish with the tab position, look at the tab item. Now the tab item is the last one on the stack, so we apply attributes to it. And then we apply the icon to it. And then we apply the closable to it, things like that. So a stack is the idea of the last thing to arrive is the first thing that we deal with. And we don't call it a line, by the way, we call it a queue, typically. Probably because line gets confused with things like, I'm drawing a line. Okay, so let's assume that this all makes sense, even though right here it's going to break, but everything else looks like it more or less makes sense. The next piece is this bit here about switching back and forth between am I an element, am I a component, and the undeclared am I directive. You can't have components inside of you can have components inside of directives. You can't have components inside of attributes. So that one won't happen. That's a non-existent use case. But now what we can say is we want to add some code in here, which will come from our current context dot render, or we call it render. Is that what we're calling this method? Generate. And it's not the current context we want, it's the previous context. Generate append of the current context. And that will give it, hopefully, enough information to say, what was the previous context's name? Because we ran the namer first, and we assigned the name. Oh, we didn't assign the name. We need to assign the name. There we go. And then the current context, once we're in here, we know the name. So we can say, root.append. And then this is a component, so it's going to be name.asElement. That's the idea anyway. Or if the previous, oh, this is all wrong anyway. All right, well, whatever. It doesn't matter because it's wrong. We're going to throw it away. Okay, we're just going to do that and just pretend that was never there because it's all wrong. Same problem up here. We're going to go ahead and do the same idea here of method body add previous context, generate append current context. So we're going to replace the append code. We're going to keep the creation code, but replace the append code just like we did before. We do, oh, I never did a super visitor here either, so we're not actually handling children anyway. Oh, I did. It's right here. So we create, we look at children, and then we append. Okay, now we need a new name for context, because this is still awful, and it's just getting worse the more I look at it, because these red lines are getting to me. Let's get rid of these. String name, we don't need mode anymore, because it's not going to serve a purpose. We don't need to reassign on our way out. Yeah, I'm going to go ahead and just delete these, because I think it's going to be simpler and obviously correct very quickly. I want a little bit of white space just for the, hey, think about this differently. Oops. These aren't going to exist. They're going to go inside of here. Component type, impl type is going to, oh, I guess we do need this. Well, we'll make a create call here. I guess we could delegate that creation too. As long as you got a reference to factory. All right, I need to change this anyway. This.factory. All references to factory should be qualified because there's only a couple of fields, and we can be pretty sure that that will make sense that way. Okay. We'll fix that later. Put some more new lines in here to be clear about that. We've got a new name we've assigned. Visit children, append ourselves, restore the stack, continue. All right, same idea here. And then now we want to visit text nodes. So now we don't have to push any stack things here, we think. We can just say current context.append text, generate append. Node.getText. And now the two different implementations can each handle this in their own way. I am going to leave that one commented out so we can clean it up later. Which means I need to do method body.add. Just put some parentheses around this first. So that's going to return a code block because it might be more than one line. Attributes are going to vary based on the context we're in. Are we appending them to a component or to an element? So now we'll say there's nothing to assemble. Yeah, well, we could say make an attribute. We have an attribute context up here, so that is the assemble bit. And by putting it here now, when we hit a reference or a text, we know how to attach it correctly. Visit children, that is super.visit node data. So now we'll recursively hit those children. It won't be very deep because it'll only be text or references. Those are the only types of things that can show up there. And then attached to parent is going to be previous context dot generate add attribute current context. And that is going to generate a code block. So now we say method body dot add code block. And we restore the old one. Attribute text now. Odds are we don't actually need very much here except to say current context dot get text. Okay, so this one here is going to be a little funny because we probably want to cast, say I know that this has to be an attribute. Because if it's not an attribute, we can't really add text to it. So that's going to be specialized. References, you could do in several ways here. And I don't think references can have children, and I don't think attribute text can have children. Let's make sure. Plain attributes can have some kind of content, and they can be string. They have no children here. So that's fine. And then reference has no children. Okay. So we'll just grab those references directly. Also. No, we won't do it like this. We're not going to say add attribute text. We're going to say add reference. And then node.getRef. And this is going to be just on the current context. We're going to mute that because I don't think that's going to matter today. Keep even internal chat. Okay, so this broadly seems to make sense. We don't have this one. We don't have events wired up yet. But this pushes a lot of the render code out to some new classes that don't even exist yet. Even the HTML entities is going to go into those classes. We're not gonna directly manage that. Text node element does one thing, component does another. We don't have anything for attributes there. I think this is complete. Attributes can have references. Elements can have references. Components can have references. They'll just be appended as strings. Okay, let's try making this class and see if it actually makes sense once we get there. So I started with a component model. Maybe model is better than context, and we just have a stack of models. And let's just rename these casts real quick to okay. And now let's try making a new class called model. No, when I hit the new class, I was expecting the new class button to pop up. Hello. Where's my new class pop up? I guess it doesn't work from there. I am running kind of an old version here. All right, we've got two different kinds of models. I'm just going to go ahead and delete these because they didn't really pan out. We're going to make a new abstract class called model. Let's first import this, and then we'll have it generate some methods for us, like generate append. And then whatever the current context is, we'll figure that out. That's going to need to be abstract because we're going to handle it differently for the two kinds of parents here, DOM and component. I'm going to just make this throw for now. Because we want this to throw if you happen to have the wrong type. All right, generate append text. Let's see here. This will apply to everything, basically. Directives, elements, components, and attributes. So we could just go ahead and reuse this for generate append text. No, we can't, because add attribute text is doing something different. Add attribute text is saying, note this text, generate the whole thing when we're done. So attributes are really different, but we still want them to follow the same basic idea here. Add reference. That one will exist for attributes, directives, elements, and components. It's the same thing for all of them. Add reference, but doesn't need to generate a code block that we append. The problem is if you have in different places you want to append different things. So for an attribute, you want to append a code block. Can we just return like empty code blocks? If so, then I can just say, hey, it's empty, never mind, doesn't do anything. Let's see. We make a builder. Code block of. You can join code blocks. Well, what happens if you don't have any? You got some collectors. Okay, it explicitly supports empty code blocks. That way you could presumably say, hey, I'm adding this to a method. Go ahead and don't do anything. Okay, cool. We can just make that be a code block then. We could do that for append text too. Oh, sorry. So now I want this to be abstract, rather than throwing an exception. And then now where we call it, we need to say method body dot add the code block. Okay, that seems okay. This is, let's see, if you see an attribute, you can get attributes added on components and on elements, but they don't apply to other kinds of models. We'll still make one anyway. We'll make this one throw, because this one doesn't make sense. But these other two always make sense to reuse. Okay. We want to change this one over to generate append reference, and then get rid of this cast, which means we could unify it with the regular append. We're going to go ahead and assign this, and then assert code block is empty, because that's how attribute text works. So I got to do events. Let's see here, directives. Okay, let's make some subclasses. Start implementing this. We'll start with a directive, since I'm not going to actually solve that one right now. Directives probably need their name. let's look at how we generate a directive. Oh, where'd it go? Order, great, there we go. So a directive, we've previously done it like this. It just generates code. We don't actually assign it to anything. But that does mean that after the supercall, we need to append the rest of it. So current context. Oh, right, because we have to do the assignment after we finish all of the children. Okay, that's somebody else's problem, which here means, you know, Colin in about a week. We'll have to worry about that. Or maybe if I'm really lucky, it'll matter to me in about half an hour. We'll just see how far we get. Somebody's talking at me. Oh, I see. Okay, so that's the first one. We'll worry about the implementation of those pieces later, because that's probably the grossest one to have to build. The attribute text always is done that way. It doesn't need its own child. Attribute model is next. Attributes can only contain text and references, and then we need to attach to the parent by saying generate add attribute, which is now the caller's problem. We probably should cast this, though. It'll make life easier there, now that I think about it. All right. Implementations, I'll have to deal with that. Component model is next. Nope. Actually, that was right the first time. I think we also want both of these. Generate append. What does append actually do? I forgot what it does. It's how to append a child, a specific child. Okay, so component will want to handle that by attaching, by adding it to its current, to its annotated at children property. Someone's unhappy. Yeah, okay, it just needs an import. We'll change the constructor to be, sure, we'll fix that later. Create class element model. Sure. And then likewise, this needs the other missing methods, because elements can have attributes and they can have children. Okay, so now we've got 4 subtypes. Model is grumpy about something, probably a missing semicolon, yeah. But this step itself says, all right, we've done the bookkeeping work. I don't know if we still want to have it create itself here, or if we want to delegate that. It looks like we're doing it here for components too. Let's go ahead and make this more readable. I think we're going to ask the context about its creation. I'm going to ask it what its component type is and what its implementation type is. But all those things really seem like they belong inside the model itself. Let's do method body dot add. I'm pretty sure all those should be add statement now that I think about it. Current context dot. So what if we just make it a create method for all of these? They don't need any other context. It's just in isolation, knowing your own type and knowing your own name, which is part of your constructor. What should you be created as? Knowing your own name makes sense for every single instance to have, because later on you'll need to say, okay, something is being appended to me. I need to know my own name so I can append it correctly. Yeah, okay, I like that. This is going to be a code block. I'm going to move it to the top because you do creation before you do anything else. We'll have to build that in the other ones. Let's do component first and get that one done. That create call done. All right. We're going to have to make getters for these because the component model needs all these bits anyway. We're going to need some way to look that up. I don't have a way to do that yet. Let's assign name. Definitely gets assigned to a field. We're going to need that elsewhere too, like generate append text, append reference. We're going to need to know how do you access children. String, I guess. We'll go with that for now. We're going to need to know the private final class name. Oops. Component type. And the implementation type. So those all have to get managed in the constructor. No, I don't want constructor arguments. I'm going to have to do some lookup to get them. So for the time being, we're going to say children accessor is always optional of dot children, and then we'll just assume there's a dot add on. But this is not going to work long term. Component type, we're just always going to say for now that that's class. Oh, do we need it? Do we need this to be type mirror for some particular reason? What did we decide about that? Component type to get this, impl type. I can't remember why we said it had to be a type mirror. Nope, I can't remember at all. It might be so we can look this up. All right, we'll come back to that. We'll have to get those figured out later. Child accessor is very roughly going to be return code block builder build. And then we say add statement, which is going to be my own name, $L. We're going to say the accessor dot add the child, whatever that happens to be, which is going to be text, I guess. So we have to wrap it in parentheses, in quotation marks. So the first one is name child accessor dot get, and then text. If child accessor dot is not present, And we'll do a toString at some point that is useful based on its component type or impl type, probably the component type. And we'll do it right now. That seems okay to me. Why are you complaining? Is that always false? No, I don't care. Oh, it is empty. I see, because then you don't need to test the negative. Cool. Generate append reference. We'll get to that later, because we're going to need reference type information. Some way to resolve that. Probably that's going to change all those call sites to fix them, but not our problem right now. Generate an append for something else. We're going to need a new way of saying, hey, how do I reference you as an element? I think we left some of this commented already. No, that's for text. We just deleted all the rest of it, because it was probably garbage anyway. If children accessor dot is empty, throw illegal state exception. And this is still wrong, but we're going to go ahead with it anyway. We're going to say current thing, child accessor, add. Oh, this is wrong here. This needs to be a create a text node. Let's fix that before I forget about it. There we go. Okay, so now we need to append its name, basically, or a reference to its element. So we'll make a new method like that. Element expression or DOM node expression? Create abstract method, yep. We're going to make this non-abstract and just throw most of the time. I don't think I can put code blocks in there. They have to be expressions, so we'll just return a string. All right, what's your problem here? What did I screw up? I probably missed a... Oh, there's a semicolon there. Okay. And reference is going to kind of be like append text, but we need a text node that we can rework. We can change as the thing is updated. We'll figure that out later. Let's see. Can this be big enough so I can make it go away? There we go. I think I'm going to move on now. We'll figure the broken stuff out later. Let's go over to the element model instead. So the element model knows its own variable name. It needs a create call. Whoops. Node expression is easy. It's just name. I guess we got to assign this to a variable first. Create field for name. Great. I guess we need the tag name too, so we can create it. And then we will make a tag name. Let's go find out where it's assigned. So we know the tag name already there. That's easy. We're going to push this into the create function because we just want to make this somebody else's problem for the moment. How do we do this for component? We said create. It knows its own name. It knows its own type. So we're just going to push this into the body.add statement. Current context.create. And then pretty much I'm just going to steal this. What's going on here? Oh, it's a semicolon. And indent. So we need to know, we don't actually need to know. We know it's always a DOM element. It's easy. We need to know our tag name. Easy. And it's pretty much just DOM element, my name equals this factory create element. Okay. Node expression is just name. It's easy because it already is a DOM node. DOM element extends from DOM node. It says so right there. Generate append text is going to be also simple. It's going to be my own name dot append quotes parentheses, and then literal text goes in there. All right. And a reference is going to be a little trickier. We didn't do this yet this call. We did this stream. We did this last time, 2 weeks ago. We have a text node, a bound text node, bound text node. So you give it the factory, and you give it the property you're going to access, the reference. So we still don't have a way to turn references into actual properties. That's a separate thing we're going to need to handle later, including resolving types to make sure they make sense. But this is pretty close to correct as it is, so we can just generate wrong code for now and get back to it. So here we're going to say add statement. It's going to be the class, so $t.of the factory, this.factory, and then $L, the reference expression. So T is bound text node dot class. L is the reference. That's not quite right. That returns a text node. So now we need to append it to ourselves. So we'll say $L is my own reference, append, parentheses, and now we've just put name in there. So it'll say, to my own name, append a bound node of the current factory and this reference. So we're going to have to find some way to dereference that. But we'll just have a compile error and we'll start figuring out what that's going to look like to actually access it. It's going to be something like .get, just tack .get on the end of it to access it. Plus, we need the prefix of how do I access it? Is it the current instance? Anyway, separate problem. Generate an append. So in other words, I need to append a element to myself or a component to myself. So what do those look like? Code block, add statement. So when I want to append something to myself, I first reference myself. I say append. I say current context has a node expression, which means get the expression that refers to that thing's DOM node, whatever it happens to be. About like that, I think. So pretty much just append, and then that has to work its own self out. For the case of another DOM element, it's DOM element.append DOM element. For the case of a component model, the accessor is going to be did I not do it? I didn't do it. Node expression. Okay, let's implement it right now, just so we've at least got this one done. So the node expression for a component model is roughly name plus as DOM. We will tidy that up someday to make that a little more flexible so that we don't have to have DOM element be the only way to build these things. But for today, that'll do the job. Okay. And then generate add attribute. So DOM elements are pretty easy to add attributes. You just say $L, in quotes, $L to refer to myself. Oh, wait, no. Well, we have bound attributes that are different. Okay, so now we need to say, hey, attribute, how do you want to be appended? So actually, we just entirely delegate this. Because now it's going to be different for DOM elements versus components. For a DOM element, we need to use our bound attribute. Move it over here. Our bound attribute will say, how does it actually attach it here? It builds the attribute, sets the value. Did I never actually make it attach? That's a problem. So right now this just returns disposable because I think we're going to want to have a way to go clean up all that stuff. But let's worry about that a little later. Let's pass root in as the first argument. Okay, and then here we're going to say DOM element. There we go. That's it. We've got an attribute. It's got a value. It's got a name. It's already assigned. Go ahead and append it. So for DOM elements, this is how you append dynamic attributes, ones that are bound, ones that need to change. For component attributes, right, so for example, this component here has an attribute. It is a constant, right? That's easy. We can assign that one way. But for a dynamic one like this, phone number view, value equals phone number view. So let's see if we implemented phone number view. Is that what I meant to say? No, what I meant to say is how do we wire this up in the implementation of create order form? Phone number view impl has a bidirectional binding from phone value to view model recipient phone. To-do, more smarts, unbind old, bind new. I bet this bidirectional binding returns a thing that we could unbind. Okay, cool. So this we inherit from Justin. He's already given that to us. Okay. Somebody's chatty. Right, let it unmute and Justin gets a little noisy, huh? There we go. Figure it out later. So this is just an automatic, hey, if you got two properties, hook them up together. So this works really well if you have an actual property. Yeah, I did. I muted it, but just for a short period of time, just in case someone does something that actually matters and I'm not paying attention. So if you directly bind an attribute to a whole value, but as soon as you put some other string in here, like my phone view doesn't correctly add, I don't know, 1 plus in the front of it, or +1 in the US. This is the US calling code, and so like a lot of things about the US, there's a lot of US things that just assume that the US is the only country in the world, including this. So you end up getting cases where your phone number doesn't have the +1 on it, so we just go ahead and always append +1. Because now it makes sense for everyone else in the world, but for us, we just ignore it. Because US is number 1, of course. We're the first. Anyway, it doesn't matter. I'm sorry for dwelling. But the point is, now you've got this formula here. We've got to evaluate the whole formula, and bidirectional binding isn't going to cut it. We need sort of a generated property instead to say, well, it's not phone itself, it's computed property. Is this even something we want to support? As soon as you dip into this, this is a single directional binding. Let's go ahead and copy this and revert the old one. Because now you can't propagate from here. What broke? Why are you grumpy now? This surely exists. Get view model. Oh, I see. It's because I renamed it. So with this one, it's bidirectional. It's properly bidirectional. We can say, when this changes, go ahead and call this. When this changes, go ahead and call this. So if you update your beans, they will correctly update the UI. And if the UI updates, because it's bound exactly to that one thing, it will correctly update the bean. But the converse is not true. If this changes, computed property will say, okay, here's my new value. But it will not work the other way around. This cannot call set on computed property. It should throw an exception. I don't see how it throws an exception, though. I'm sure I just don't understand it yet. Evaluator is here, evaluate, call set value every time it's evaluated. Okay, so we need some kind of magic to hook that up to say automatically call evaluate. Because it looks like, Justin, it looks like computed property will allow you to just call set value and say, no, here's a non-computed value that you should use instead, which might not propagate backward. It won't propagate backward because there's no way to push it backward through the supplier. Okay, well, that's a problem to look at later. Okay, so yeah, it's been a while for me too. I'm just trying to not move backward here. So for elements, it's a little more easier, right? We said that as long as they're constants, maybe we can ask the attribute, hey, are you a constant? If so, I'm just going to go ahead and append you. And if you're not, I'm going to use the bound attribute and say, here's a lambda, figure it out. For components, if it's a constant, we can just assign it. If it's just a reference, we can use bidirectional binding, and ask it to be bound both directions. But if it's an expression that mixes strings and properties, we have to give up one of the directions there. We could just say don't allow that. You have to make your own computed property to handle that. I don't really like that answer, though. Looks like I'm missing some things in there and an attribute. Okay, that's fine. We can come back later and finish that. So let's do the element add attribute. So I guess we're going to want something like, oops, that's caps lock. If attribute model is string constant, then it's pretty easy. We just say append a reference to me, set attribute, quotes around the name of the attribute, and then quotes around the contents. Name attribute model dot get name. And then get expression. We don't want it to be, I mean, I guess an expression works. We could just wrap it in a lambda up at this level when we do have dynamic code. Let's just do a get expression for right now. We'll see how much we hate this. If it is a string constant, otherwise, now we do bound attribute. So we will just say $L T to say the bound attribute type of this dot factory. That's always a constant. The element, which means my own name, so $L. The next thing to pass is the generated value. That's the lambda here, which will be like this. And then inside of here, we will have, we'll just do $L. We won't do curly braces because then you need to return also. And then references. We'll just put $L there, and we'll figure it out in a minute. So now we need to say, oh, we need the name of the attribute. Did I not do that? Element, name of attribute. So, factory, my own name, name of attribute, which we just said is going to be this thing here. The expression. And then get referenced expressions, get references. We'll just say that there's going to be a string that does that for us. Oops, let's generate that for me. Create method, get attribute name in attribute model. That'll be a string. We'll come back to what it actually does in a minute. Get the expression, whatever that happens to be. Create method get expression. I don't think I want quotes on this. I think I want the expression to contain the quotes for me. Create method get expression, an attribute model. I think I forgot a closing parenthesis here. And then references will be a string also. Create method get references. We'll just have to keep track of those as we go. So now we're going to have a constructor. Let's see, where do we build attribute models? We build them here. We don't have we have the attribute name. So we need node.getName. The expression we built as we append junk to it and append references to it. So we'll have, oh yeah, we got to make our booleans here too. is string constant. Create abstract method is string constant in attribute. Okay, and then eventually we'll need a separate one of these for is single reference, except spelled properly. Okay, we'll get to that one. Let's implement these appends real quick, because that is going to let us build these out. So we're going to track the strings as they're added. Although I guess we could just concatenate. Oh, no, we need to be able to interpolate them. Oh, that's not going to work right. References, I guess references will be strings now for now too. No, let's not do it like that. Let's say references dot join. How do you do this new string joining thing? It's not really that new anymore, I know. Delimiter is going to be comma. Prefix is going to be java.util.set.of. And suffix is going to be close parenthesis. And then we want to handle the whole this feels really dumb. It's got to be a better way to do this. Okay. Anyway, that will make a set of references. Is string constant, return references dot is empty, is single reference, return text that is empty, and references dot size equals. And then an expression. This one's a little trickier, because now we got to do that zipper thing. We got to say, okay, there was a string and then a reference and a string and then a reference, and then a reference and then a reference and then a string. So that is where I think we'll pick up next time. Here's where we're going to append this thing. We're going to say generate append text. This is always going to return an empty. All right. So we need to zip them together. What aren't you happy about? Create. Implement create. Create is going to do nothing, so we'll just say, oops. There we go. Model is unhappy because of other references to it. Directive is unimplemented. Element is unhappy because why? Semicolon. Cool. And finally, component is unhappy because I haven't assigned these. Okay, so we're gonna need some bookkeeping there to be able to do the mapping back and forth between, hey, I've got a class name up here, and I've got a bunch of components here. Let's go find those and look them up. And then bindings is gonna need the same thing. So before I even build directives, we're gonna do, we're gonna finish off component and do all those lookups. All right, okay, I am gonna hang up here and get some lunch in my stomach and make some more coffee because this has been empty for kind of a while. I kind of lost track of that. Oh, string join, would that do it? Would string join be an easy way to do that? String joiner is relatively new, I think. I want attribute instead. Where's the attribute model? There it is. The string join also have the nice little iterable. Yeah, it does delimiter, but I need prefix and suffix. I guess I could just concatenate those directly. Yeah, whatever, it's fine. Someone can make a pull request if they hate my code. Yeah, all right. Take care. I will see you next week. I'll be back. Justin's gonna probably stream later this week. And in the near-ish future, Ahmed is gonna join the rotation here. I don't know what the hours are gonna look like. But either he's gonna be working on Domino, or maybe he can play with some of this once it actually works, and show me why this whole idea is stupid, and what else we're forgetting to be able to make it actually do productive things. Maybe some TypeScript stuff too, that'd be great. All right, Friday, Justin's on Friday. Awesome. All right, thanks for hanging out, and yeah, be back next week.